So this video is going to be on two ideas. One that you're going to write in your composition book and one that you have a handout that you're going to fill out. Okay. So this is going to be on something called standard deviation. That's something we should have seen in integrated one. Some of us might have, some of us might not have. So I want to just explain what it means. And normal distribution. We're going to have two handouts on normal distribution. One, how to put the information into your calculator, and then one that I'm going to work out the problems, and you're going to put them on the paper that's handed to you, and you're going to put into your composition book. Okay, but the part that I'm writing right now, you're going to write in your composition book. So standard deviation tells us how spread out the data is. So standard deviation. And what we're going to use is a Greek letter called sigma. Okay, Greek letter called sigma. And it represents how spread out the data is. So sometimes you can have a mean that is the same as another mean. And you might think that the data is spread out the same, but when you look at it, you'll see that it isn't. So this kind of tells us a little bit more than a mean would. So the example I'm going to do is going to be the heights of 5 dogs in millimeters. Okay. And so let's say that their heights are the following. 600, 470, 170, 430, and 300. Now, in order to find the standard deviation, the first thing you're doing is going to find the mean. And to find the mean, which we call X bar, what you're going to do is you're going to take all the data and add it up. 600 plus 470 plus 170 plus 430 plus 300. And you're going to divide it by how many items you have, which in this case we have 5. When I do that math on top, I'm going to get 1,970 over 5. And when I do that division, I get 394. That is my mean. Okay, that's the mean of this data. Now, to find our standard deviation, I'm just going to scooch this up. To find our standard deviation, I am going to make a table. And again, this is something you don't have to do for all of our problems, but I want you to have it in your notes so you understand what it means. So I am going to basically have a column for the heights, a column for the heights minus the mean. So heights minus the mean, I'm going to write it as X bar. And then a column where I square those values. Okay, we take the heights minus the mean and then we square them. So I have a 600, a 470, a 170, a 430, and a 300. And then I am going to take each of them minus the mean. And I'm going to be doing that math. Let me just write these first. So 600 minus 394, 470 minus 394, 170 minus 394, 430 minus 394, and 300 minus 394. And when I do these, I get the following values. So I get a 206. Here I get a 76. So what the 206 means is I'm 206 above the mean. Okay, taller than the mean. On the next one, 76, taller than the mean. The next one, I'm going to get a negative. Get a negative 224. So we're 224 less than the mean. The next one, we get a 36. And the next one, we get a negative 94. So we're 94 below the mean. Now, what can happen is we're going to be averaging how far off we are from the mean, but sometimes a positive and a negative can cancel out and make you think that the spread is 0. So what we do is the next column, we square these. So I'm going to take the 206 and square that, my 76 and square that, negative 224 and square that. Now, when we square something, we always put it in parentheses so that if it's a negative, remember, a negative squared should be a positive. Okay. So I'm just writing all of these out as squares. Now, 206 squared is 42,436. 76 squared is 5,776. Negative 224 squared is 50,000. 50,000. Apologize. 50,176. 36 squared is 1,296. And negative 94 squared is 8,836. Now, we're going to average these, okay? And so what that means is I'm going to take these, add them up, and divide by how many items I have, which is 5, okay? So let me do that down here. I'm just going to scooch this up a little bit. So this is going to be called variance. And variance is going to be our sigma squared, okay? And it's the average of these squares, okay? It's the average of these squares. So we take 42,436, add it with 5,776, add it with 50,176, and with 1,296, and 8,836, and we divide by 5, okay, because we're averaging it. We have 5 items. Now, when I do that on top, I'm going to get 108,520 divided by 5, and that's going to equal 21,704. Now, we are not 21,704 off of things on average because all these values were in the hundreds. Remember, we squared. So our last step to get our standard deviation, okay, and again, you're jotting this down. You are not going to be asked to do this by hand right now, but I want us to understand what the number means. And so this is going to be, I'm going to scoot it up a little bit more for myself, okay. This is going to be standard deviation, and standard deviation is sigma. Okay, it's sigma. And so what I'm going to do is I'm going to take the square root of the variance. So that means I'm going to take the square root of 21,704. And when I do, I'm going to get 147.32. And that is our standard deviation. So that tells us how far off we are from the data. Okay, that is what variance is. And the smaller the standard deviation, the closer the data is to the mean. The bigger the standard deviation, the more spread out it is. So let me just write that. So the smaller the standard deviation, the closer the data is to the mean. And the larger the standard deviation, okay, the larger the standard deviation, the more spread out the data is from the mean. Okay, and that's standard deviation. Now, our calculators find standard deviation. So we are not going to have to be doing this. And on most of our problems, we're going to be given the standard deviation. But I want us to understand that that means how far we are from the mean. So just to show you guys how you can do this, okay? We would go to stat, the stat button. I would go to edit. I'm going to clear what I have here. So I'm going to come up here. I'm going to press clear, not delete, clear, and then enter. And then I'm going to put in the heights of the dogs, okay, which was 600, 470, 170, 430, and 300. And these calculators do standard deviation. So if I press the stat button and I come here to calculate, I can come to number one variable statistics. Okay, and I'm just going to hit enter, 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 because L1's where my data was. You see it actually computed my mean that I had, X bar. This here is just if we had added up all the data, it ended up being 1,970. And we saw that when we added it up and then we divided by 5 to get our mean. This next one here, this one here is our standard deviation. Okay, you see the 147. This is also another standard deviation. This is the one I used because I did the standard deviation for the whole entire population, the whole 5 dogs. This one's if I'm doing it for a sampling. And so instead of dividing by 5, because I had 5 dogs, I would divide by 5 minus 1, which is 4, if that was a sampling of dogs. Okay, but we're dealing with this one right here, sigma. Here you see you have 5 items. And then this is getting down into the box and whisker information. But you see that the calculator does do this. Okay. Now, what we're going to be talking about next is normal distribution. And just looking at these histograms here, you see this one, this distribution is kind of more going to the left. Okay. So here it's higher, and then here we say it's skewed to the left. This one here we say skewed to the right. Okay, where here's the bunch of the data here on the right side, but then you've got this that's dragging out to the left. We say that's skewed to the left. This one here we say is skewed to the right. And this one's kind of a mix match of a whole bunch of different things. Now, the type of distribution that we're going to be dealing with is going to be the following. It's going to be something called a normal distribution. And a normal distribution is going to fall within a bell-shaped curve. You can see it's symmetric. Okay, symmetric. This is the data that we're going to be doing. Now, when we have data like this, it's special and it's going to be symmetric. You're going to have half the data on this side. You're going to have half the data on that side. Okay. Now, when you are looking at this, we talked about standard deviations. For a standard normal curve, we have a mean of 0 and a standard deviation of 1. Okay. And so if I'm going 1 away on either side of my mean, which is 0, your mean's always in the center here, that's going to be 68% of the data. Now, if we go 2 deviations away, okay, 2 deviations away, we're going to have 95% of the data. When we go 3 standard deviations away, we're going to have almost all of the data, 99.7% of the data. Now, this is when we have something called a standard normal curve. So now I'm going to switch to the paper that you guys are going to have gotten from the sub, and you guys are going to fill in the data on that. So let me pause this for a sec. So now we're looking at this worksheet, okay? And this is going to be on normal distributions. So let me kind of zoom in on this. So normal distributions when data varies randomly from the mean in a shape of a bell-shaped curve. Every normal curve has a symmetric bell-shaped curve. When the outcomes are normally distributed, you can sketch the graph of the distribution. The highest point of the normal curve is directly above the mean. Okay, that's in the middle. That's going to be your mean. Now, a standard normal curve, which is what I mentioned a second ago, has a mean of 0. Okay, so let me kind of highlight that information. Okay, so a standard normal curve has a mean of 0. Sorry, I'm trying to get this to mean of 0 and a standard deviation of 1. Okay. The area between a standard normal curve and the axis is equal to 1. Okay. So let me just highlight that. Okay. So the standard normal curve and the x-axis, the area under that is 1. Therefore, the area under the standard normal curve is used to find probabilities of data that is normally distributed, even if the mean is not 0 and its standard deviation is not 1. So I'm going to first talk about a standard normal curve where our mean is 0 and our standard deviation is 1. And then we're going to do ones that are not a mean of 0. But since probabilities are out of 1 and the area is equal to 1, we can find the area and that would represent the probability. We can also think of it as percentages, okay? So an area of 1 would be 100%, okay? So we can also find percentages. Now, here it says, as seen below, about 60% of the data falls within 1 standard deviation of the mean. And about 95% of the data falls within 2 standard deviations of the mean. And 99% of the data falls within 3 standard deviations of the mean, if the normal distribution is normally distributed. So let me just kind of scooch that up here. Okay, so you guys have this on your paper. So right here, the area here, this on both sides is symmetric. So one side is 34%, the other side is 34%. And I'll show you how we got those numbers. Okay, so that's if I'm going if I'm 1 standard deviation above or 1 standard deviation below my mean. And my mean is right here in the center. And in this case, my mean is 0 and my standard deviations are 1. Now, if I go out 2 standard deviations, so going out 2 standard deviations is going to be anything at all in this region. You can see that we have here 34 and 34, which made 68. And we have a 13.5 and a 13.5, and that's going to be a 27. And if I take 34 and 34, which is 68, and I add it with 13.5 and 13.5, which is 27, I end up getting 95%. So that's where they got that 95% falls within 2 standard deviations. Okay, so here you see them saying that 68%, the 34 and 34 is 1 standard deviation. And here this 95 is 2 standard deviations away. And then if I then add on to it this section and this section, okay, so I had my 95 and now I'm adding on to that a 2 and a 2. So when I take 95 plus 4, I get 99%. And here, this is that 99%. Almost all the data falls within 3 standard deviations. Now, not exactly 100%, so you have a little bit that's out on either side. 0.5% on this side and 0.5% on this side, okay? That is what a standard normal curve looks like. So you have a mean of in the center of 0 and a standard deviation of 1. Now, how I get these values, we're going to get them from our calculator, but I added on to Canvas a table, and let me show you guys that table. And so in Canvas, I did have a normal distribution table, okay? And what we have here is how many deviations we are from here. So if I'm looking at this and I come down here to 1 right here is that 34%. Let me just kind of underline that. Get this. So here is that 34%. Now, these other ones would be, if it's not exactly 1, maybe it's 1.01, then it would be 34.38, or 1.02 would be 34.61% of the data, okay? Now, if I go down to 2, from 2, that's going from here to here, from 0 to 2, okay? So from 0 to 2, it is 0.4772. Now it's going to be 0.4772 on both sides, okay? And that's if I take 0.4772 and I double it, I end up with 95.4. So when we have these values, it's only this shaded region from 0 to 1 was the about 34. But if I'm going 1 deviation away, I'm 1 this direction and 1 this direction. So 34 and 34 made up the 68. And then if I'm going here, and we're saying that's about 0.4772, it's also 0.4772 on this side. And when I take 0.4772 and I double it or add it to itself, I end up getting 0.9544, which was that 95% that we found. And then if I go down to 3%, which is here, or sorry, 3 standard deviations, get it back and highlight. I'm right here, which is a 0.4987. And so 0.4987. So if I take 0.4987, which is going from here to 3, and then if I double that, okay, so let me take 0.4987 and double that, I end up with 0.9972, which is about 99%. And again, since I doubled it, it's from here to here. And that's how I would use this table. Okay. Now I gave us a second table, and this table is going to look slightly different. And what you'll notice is I'm going not from the center to my standard deviation. I'm going from the end to my standard deviation. So here, if I'm looking at 1, I'm just going to show you guys that 1 is not the same as I got on the other one, because what's happening is it's going from here all the way to 1. Now, if I split this in half, I know that this is 50% and the other side entirely would be 50%. So when I have my 0.8431, it's that plus the 0.343113 that I had from the table above. So remember, when I was up here, going up to 1 deviation from 0 to 1 deviation, that was 0.3413. This table is going to be 0.5 more because each of these I'm adding 0.5 onto it. Now, if we look at the 2 standard deviations here, okay, so 2 standard deviations is 0.9772. And remember up here, it was 0.4772. And again, it's 0.5 more because I'm not going from the center out on this table. I'm going from here to 2. And so I have my 0.5 plus my 0.4772. 0.4772. And that's giving us the 0.9772. Okay. So I'm just showing you this so you guys understand the numbers when you see them. And so again, on this table, 3%, I keep saying 3%, 3 standard deviations is 0.9987 because I'm taking the 0.5 and I'm adding it to the other side, which is 0.4987. So 0.5 and 0.4987 together is going to add up and give us the 0.9987. So I'm giving you these tables in case you need to reference them. And I just want you guys to understand the difference between both of these tables I gave us. One of them is going from the center out to 1 deviation, or even if you want to go just center back to -1, it would also be 0.3413 because it's symmetric. This one here is not going from the center, it's going from all the way on the left side. Let me make it a little bigger. All the way on the left side to whatever your positive standard deviation is. Okay. So let me get back to our paper so that we see that. So again, that's where they're getting the 68. This is about 34% and 34% together, that's 68. Going from 0 to 2, 34 and 13.5, and then 34 and 13.5, that adds up to about 95%. And then going from 0 to 3, adding that extra 2 and extra 2 here, that gets me 99% of the data. And then there's some data out here and here. Okay, 1%, which is 0.5 on this side and 0.5 on this side. Okay, so now we don't always have things that are a standard deviation of 1. So what's going to happen is when we draw these things out, we are going to use this idea and we're going to be drawing this out the same as we did the other one, but when they say that our standard deviation is 3.1, every one of our deviations, we're going to go out 3.1. So in this particular situation, we have a given population of sharks. The mean of the jaw width is 15.4 inches with a standard deviation 3.1. Sketch a normal curve showing the jaw widths at 1, 2, and 3 standard deviations from the mean. So for this, okay, I am going to draw a normal curve. In the center of it is going to be my mean. And my mean in this case is 15.4. And then we're going to go out 1 standard deviation. This would be a positive 1. This would be a negative 1. And what I'm going to be doing is I'm going to be adding 3.1 on because every deviation is 3.1. So my next value is going to be, and I'm just going to shrink my pen. I should write this a little smaller. So this one was 15.4. When I add 3.1 onto 15.4, I get 18.5. When I subtract 3.1 from 15.4, I am going to get 12.3. And then I'm going to go out 2 standard deviations. So when I'm going to go out 2 and -2, okay, standard deviations, I keep on adding 3.1 and taking 3.1 off. So when I add 3.1 to this, I get 21.6. When I take 3.1 from 12.3, I get 9.2. Then I'm going to go out one more. So I'm going to go out 3 standard deviations and -3 standard deviations. And when I add 3.1 to 21.6, I'm going to get 24.7. When I take 3.1 from 9.2, I'm going to get 6.1. And that would be a normal curve for this situation. And again, our mean is always in the middle. My X bar is in the middle. And then I'm going out 1 deviation on either side, and I'm adding the 3.1, subtracting the 3.1. Then I'm going out 1 more standard deviation, and every time I go out, I'm adding 3.1, taking off 3.1. And that's a standard normal curve. Now, just so you understand, let's say I wanted to figure out how many deviations out a particular jaw width is. So we have something called a z-score, okay? I'm going to write it here, but I'm going to zoom in so I can write, okay? So something called a z-score is how many deviations off a particular value is. And so you're going to take your value, you're going to subtract it from the mean to see how far off it is, okay? And then you're going to divide it by the standard deviation. And let me just write this out in words, okay? So this is the value minus the mean divided by the standard deviation. Now, again, they're going to be giving us this information and we're going to be using our calculators, but I want us to understand the concept. So let's say I wanted to know the z-score for, let's say, 15 inch jaw. So I know that the mean is 15.4. So I would take my number, subtract the mean, which is a 15.4, and divide it by the standard deviation, which is 3.1. And I'm going to put this into my calculator. So I'm going to take 15 minus 15.4, and I'm going to get, I'm really -0.4 off of the mean. So that means I'm not even going to be 1 standard deviation because each standard deviation is 3. So when I divide it by that 3.1, I get a z-score of a -0.129, let's say. Let's say about a -1.3. So that is what a z-score is, okay? Now, I'm going to take a look now at this example here. And so this example, it says, in a survey, the responses to the question, how much time do you spend in the shower every day, were normally distributed with a mean of 15 minutes and a standard deviation of 2. Sketch a normal curve and show the times at 1, 2, and 3 standard deviations. So I am going to have my standard, my bell-shaped curve basically. My mean is going to be here. I'm going to be going out 1 deviation on either side, 2 deviations on either side, and 3 deviations on either side. Now, my mean was 15 minutes. So I'm going to put 15 here. And my standard deviation is 2 minutes, okay? So since my standard deviation is 2 minutes, I'm going to be adding 2 on to get 17, then 19, then 21. And then I'm taking 2 off, so it's going to be 13, 11, 9. that would represent this situation. Now they're asking us some questions based off of this. So it says, what % of the responses would you expect to find that are between 13 and 17? So if I was to look at this, okay, and recopy this, I'm going to copy this, but you guys would be copying this. Okay, recopying it. Let me just see if I can get just that, or is it going to give me everything? So I'm going to recopy it too. So if I'm doing this, okay, here is our 15, here is 17. So I really want here between 13 and 17. That's what I want. Now, in this case, these happen to be nice standard deviations. Sometimes they aren't. Sometimes they aren't. So we want to figure out this area here. Now, we could figure this out because we have learned that 68% of the data is between one standard deviation away, but we're not going to have ones that are always nice. So we're going to learn how to do this on our calculator. So on our calculator, we're going to use something called the normal CDF. And for the normal CDF, when you use it on your calculator, it's going to ask you for a few things. It's going to ask you for your lower bound. It's going to ask you for your upper bound. It's going to ask you for your mean, okay, which is our X bar. And it's going to ask you, I'm going to put SD for standard deviation, but standard deviations are sigma. It's going to ask you for those. So what we're going to type in is, when we do this, we're going to have a normal CDF. Okay, and I want us to write this. This is what we're going to type in our calculator, and I'll show us how in a second. But I want to always see what you're putting in your calculator. So 13 to 17, upper and lower. My mean is 15, and my standard deviation was 2. So to put this into our calculator, okay, let me just get my calculator up. So what I'm going to do is I am going to go to the button that says distribution. Okay, it's on the vars, but it's the distribution. So anything in blue, I need to press the blue second button and then this. And then it's going to give me these. And I want number 2, normal CDF, not normal PDF, normal CDF. And then I hit enter. And then it's asking me for the lower bound. Now, this lower bound that they have in here is really negative infinity. It's really negative. It's negative 10 raised to the 99th power. That's really what it is. So if I was to type in negative 10, not minus, but negative 10 raised to the 99th power, that is really a lower bound of negative infinity. An upper bound of positive infinity is 10 raised to the 99. Now, that wasn't our lower and our upper bound. Our lower and upper bound, let me get up here. Our lower bound was 13, and our upper bound was 17. Our mean, okay, they call it mu, but that's our mean, okay, is 15, and our standard deviation was 2. Okay, and then it's going to say paste. So it pastes it on my page, and then I hit enter, and it's going to give me 0.6827, let's say, and that's going to be our answer. So I'm going to put that. So that is going to be my answer. It was 0.6827. That is it as a area out of 1. As a probability, as a percent, I'm going to move my decimal 2 places, and it's 68.27%. That's my answer. So in the next one, again, when I'm doing this, these may not be my nice deviations, okay? But I put my mean in the middle, which is 15, and I want to know what the probability, so this time it's probability, not a percent, is either less than 12 or greater than 21. So I want less than 12, which is going to be this area here, or greater than 21, which is this area here. So I'm going to need both of them. So in this case, I'm going to get two answers and then I'm going to add them together. So I am going to do, here, let me color code these. So let me do one in purple, and let's say I do one in this teal color. Let's try again, teal. Okay. So for the purple color, I'm going to do the normal CDF. And what I'm going to put in is my lower bound, which is going to be negative infinity. Okay. Because I'm going from negative infinity up to 12. But I can't put in negative infinity. So I'm going to type in negative 10 to the 99. That is negative infinity. My upper bound is going to be 12. My mean was 15 and my standard deviation still 2. Okay, I'm going to put that into my calculator. For the other piece, I'm going to be putting that also into my calculator. And for this piece, I'm going to have a normal CDF. I'm going to write it below here. My lower bound is going to be 21. My upper bound is positive infinity, but I can't write positive infinity, so I'm going to say 10 to the 99. My mean is 15 and my standard deviation is 2. So I'm going to put that into my calculator and get those answers. So for this, again, I'm going to press on the calculator second and bars for distribution. I'm going to come here to number 2, normal CDF, and this time I'm doing the lower bound, which is negative 10 raised to the 99. My upper bound is 12. My 15 and 2 are going to stay. Okay. I'm going to get that answer. Okay. And I'm also going to be adding that with the following. So let me do second and distribution again. Number 2. This time my lower bound is 21. My upper bound is 10 raised to the 99 because that's infinity. And then 15 and 2. I'm going to paste that. And when I add those together, my total answer is going to be 0.06815. And let me just do this. Let me just get rid of this plus here. And let's see. So it really was a 0.0013. And this one here is a 0.0668. And so when I added this one with, and I'm just arrowing, let me see, sorry. When I added this one with, and I'm going to highlight, it's hard to see the highlight, with my answer from the top, adding those together, you see I got this answer here, that 0.06815. So let me just jot these onto my paper. Okay. So this one here was 0.0668. We're going to do 4 numbers after the decimal accuracy. This one here is 0.0013. And so when I add those together, okay, when I add this with this, the total is 0.06815. So I'm going to say 2. And that's going to be our answer. So on the next one, this one's going to be a slightly different question. Same situation, same mean, same standard deviation, same situation of shower times. But this time they're telling us how many kids we have. It says we have 70 students who were surveyed. And we want to know how many, not the probability, not the percent, how many. But we're going to find the percent first. That's what we're going to do. So in this situation, again, my mean is 15. I want from 11 to 18. I'm not drawing this necessarily by scale. And so I want to find this area right here. Okay, that's the area I want to find. So when I'm trying to find this area, I am going to be, again, doing normal CDF. Normal CDF. I'm going to put in my lower bound, which is 11, my upper bound, which is 18, and then that mu, okay, which looks like that. That is our X bar, okay? So our mean is 15 and our standard deviation is 2. So I put that into my calculator, okay? So let me do that again. So I'm going to go second and the vars button for distribution. Okay, I want number 2, normal CDF. And we were doing it from 11 as a lower and 18 as an upper. Still 15 too. And this is going to get me the percent. So about 91%, 91.04%. Okay. So let me write that on my paper. Now, what I'm going to do, let me just do the math here since I have the calculator. That's the percent, about 91%. 91% of what? Of 70 students. So I'm going to times it by 70 because that will find 91% of 70, which is going to be 63.7. Okay, about 64 students. Okay, so then I'll put that on my paper. So when I worked that out, again, we ended up with 0.9104, okay, 0.9104. Okay, and just understand that that means 91.04%. And so I wanted to figure out how many people out of 70. So I'm going to take 70 and times it by 0.9104 because that will find 91% of them. And when we did that, that gave us 63.7 students. Okay, so about 64 if you're rounding up. So you have 3 situations here. One of them, when, let me just move this. I don't know why that got moved. One of them where they wanted the percent. Okay, so that area represents percent. You just need to move your decimal 2 places to rise the percent. Then they wanted the probability, which I just left it as a decimal, 0.0682. Then the last one, they want to know how many people out of something. So I needed to find the percent, and then I times them total by that to figure out how many students were in that category. Okay, now this last situation is going to be slightly different. This is going to be a 4th situation. So it says entry to a certain university is determined by a national test. The scores of this test are normally distributed. Okay, let me kind of highlight this. Normally distributed with a mean of 500 and a standard deviation of 100. Tom wants to be admitted to this university, and he knows that he must score better than at least, so he needs to do better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? So I'm going to draw out the situation. Always draw out the situation so you can see what's happening. Okay, our mean is 500. Okay, our standard deviation is 100. So this is going to be 600. Let me draw this out a little bigger for myself. Let me zoom in. I'm going to zoom in so I can draw this better. Okay, so for this, okay, here is 500. This would be 600. 700, 800. This would be 1 deviation away, 2 deviations away, 3 deviations away, okay? I'm not drawing the other side because I'm going to be at 585. So 585 is going to be somewhere in here is 585. And we want to know, is that in the top 70%? So what that means is all the way up to here, we want to figure out what percent this is. What percent is this? Okay, what percent is this for 585? What is the area? So this is going to be done slightly different. This one, we're going to do something called the inverse. Well, let me say, we can do this with the normal CDF. So for this, I'm going to do the normal CDF. And I want to know what is the area from negative infinity and negative infinity. Instead of writing negative infinity, I'm going to go negative 10 to the 99 up to 585. And I know it's more than 50% because it's beyond 500. So it's more than 50%, but I just don't know where it is. And then my mean is 500 and my standard deviation is 100. So I'm going to put this in my calculator to see what I get. So I'm doing second and the vars button for distribution. I'm going down to number 2. My lower bound is going to be negative infinity, which I type in as negative 10 to the 99. My upper bound was 585. And the mean for this was 500 and the standard deviation is 100. And then I'm going to hit enter, enter. And it gives me 0.8023. Okay, 0.8023. So this ended up giving me 0.8023. So he's in the top 80%. Okay, he's in the, well, I shouldn't say he's in the top 80%. There are 80% of the people he's better than 80% of the people. He is better than 80% of the people. Okay. So in the next one, it says, what is the lowest score that will allow him to be admitted to the university? Okay, so he's beyond. We want to basically know where is that 70%. So if I have my standard normal my normal distribution, we have 500. We want to know what value, I'm just going to call it X, what value would give us in this situation from all the way from there to here, that this is 0.70. Okay, that's what we want. So this time, I don't know the upper and lower bounds. I want to find the area. So I'm going to do inverse norm is what we're going to do. And for the inverse norm, what we're going to want is the area. Okay, let me write it like this. We're going to want, and the way, so we're going to want the area, then the mean, then the standard deviation. I'll just put SD for standard deviation. So we're going to type in the inverse norm for, let me write it here, 0.7. My mean was 500 and my standard deviation was 100. And it's going to give me back the value. So we find this in the same spot on the calculator. So I go back to second and distribution, just like the other one. And you see number 3 right here is your inverse norm. And so here it says area. Area is the percent, but we're going to write it as a decimal. Okay. The next one is our mean, which was 500. The next one is our standard deviation, which is 100. And when I press this, it's going to tell me 552.4 is the score that you need. That's going to be at the 70th percentile. So let me jot that down. So when I put that into my calculator, I get I get 552.4. That's the score. And so when you're doing this, what you can write is inverse norm. Okay, and then you give me parenthesis, you put the area, which was a 0.70, you put the mean, which was 500, you put your standard deviation, which was 100, and then you get that answer. And we use that when we know the area or the percent, and we want to find the value that's at that area or percent. So, good luck on your assignment. I'll try to post a video help for that also for you guys.